Oh, hi. My name is Chris Fernandez. I am an SE for Keysight Technologies. Today, I'm actually going to start a video series here. I'm going to try to create a video series to kind of give you how to set up the FRDM board RT1186 from NXP. And I'm going to try to create a video so that I wish I had a video like this before. It would save me a lot of headaches and trials and stuff, but I guess it's from trials that you kind of succeed. So the goal is to show you how to go from opening the box for the RFDM all the way to uh, uh, checking QBV. So for in terms of topology itself, I'm just going to be using Novus Mini. In case you don't know, Keysight creates this little box that I can do it from my desk here, and I can do the same i.MX network and TSN testing based on just the Novus Mini. So to start, just take a look at the board itself. The board is sitting here on my desk, so I kind of have a visual cue to it. This is what the board looks like. You're going to be using the board, this USB here that says USB from the one that's right next to the power here. So the power is unplugged, and it's going to grab the power from this USB here that says debug USB. So this is the main USB drive that you're going to be connecting to. For the testing, for our testing, we're going to be using those the eNet0, which is if you look at the board from the front, it has two distinct, or it has four RJ45. We're only going to be using this one here. That's eNet0, which is on the top, and eNet2. That comes along. That comes as an important feature later, and I'll show you how. And this dip switch here right now is the default is set to 001. The only really two defaults that we're going to be playing around with for this demo is going to be 001, which is the default, and the 100, and I'll show you the explanation why. And so in terms of actually what's plugged into the board, I have this USB here that I'm going to be using as a COM for my testing and my communication to the board itself for the terminal, and my two ports here. So Ethernet, the one that says eNet0, the top one is connected to my port 1 on my Mini, and the bottom one, which is eNet2, is connected to my port 2 on the Mini. As the board is just working along, the dip switch here is set to 001. And also I have a connection to this USB as well. It's using the same core. It's not using the same ports on the PC. Sorry, but it's the same kind of a data type of connection between this board and here. This OTG USB here is what I use to whenever you compile the code and you want to build and write to the board itself, that's what you're going to use this connection to. So I keep it connected. You don't have to, but usually that's how, if you want to write something to the board, that's what we're going to use. So in terms of looking at the board itself, the things that you have to do to get things going in the beginning is highlighted here, and I'm going to go over it in the next few slides here. So just right next to the USB that we use as for connection to the board, there is a debug. It's called J34 right here. We need to remove that, and I'll show you why. When we connect to the board using the console, you're gonna see that if you don't remove this, you won't be able to press insert and go into the prompt that gives us the ability to configure TSN. So you're gonna remove this J34 out, and you're going to configure those J12, 13, 17, and 18 in order for the DUT or this board to use the the Ethernet 1 and 0 and 2 here on the right side of the screen here instead of the left. By default, it's configured to be using the left side, those two ports here, which are used for industrial testing. In my case, we're using TSN in automotive testing or automotive-like testing, so we're going to be using those two here on the right. So we have to modify those jumpers here, the 12 and 13 and 17 and 18. And here's what you need to do for those two. So on J18 and 17 has to be 1 and 2. And then on J17 is 2 and 3. And the 12 and 13 here is the same thing, 1 and 2 and 2 and 3. And this is what this those two ports here are what they call a J56. So you're going to see that on the screen here when they talk about J56 A and B. It's referring to those two ports. Um, one one thing that I noticed that if you messed up this or if you don't have this configured here, the board was going to try to communicate using the other the J57, which is those two on the left side here. So just be aware that's what you need to do to get going. So it's changing those jumpers here to use the correct ports. And this here is the explanation about removing the J34 jumper so we can get to the debugger. So in terms of the jumper itself, the 001 and the 100, this is the explanation here from the manual itself. I'm using 001 when it's regular mode and you're just accessing the board as is, and you create, and then you put it into 100 when you want to write to it using this serial port right next to it. Okay, so this is all I want to cover for this. And then I'm gonna go jump right into my board right now that's up and running, so you kind of have a feeling. So I'm gonna use mobile term here, and I'll show you what I'm talking about in the configuration of the serial. So I'm gonna go into the serial, and when I look in here, I see two ports here. See port MCU link VCOM port 2 and port 1 here on 9. So this is the serial, this is the connection to the board itself, the main connection. So when you click on it, uh, under terminal settings, go under expert settings and do implicit CR on every LF. If you don't do this, it will just look weird. The default looks just look weird. It comes out at a little step like, and under the flow control here just says none, and this is gonna give you the ability to connect to the board itself. As you can see, it doesn't look too good, so let me kind of redo this connection. Stop here, and then I'll redo it and see if where did I mess up. So under serial, I'm gonna go into this port here. The speed is 115 to 12. Terminal under terminal settings, expert settings, I'm going to implicit CR, and I'm going to click OK and OK. And that should give you this. So the board, when it's operating in normal mode, you're going to see this going across the screen. As soon as we do the build and we build the TSN image to this into this board, you're going to see this scrolling all the way, all the time. In order to stop that and go into more configurations that you can do, you're going to be pressing insert on your keyboard, and that's going to give you this prompt called bridge. In here, you can do help, and that's going to give you all the commands that you can in for this board. So this is what we're going to use later on this on the video here to configure the VLAN, to configure forwarding table for the little switch that we created. And so you can do help plus the other stuff here. And as you can see here, QVV will be set here. So you can do things like help config and then QBV, and it's going to give you all our help config VLAN and so on. Anyway, this is all I want to cover for now. The other USB port is not connected here. In terms of PC or what do you need to get going and get configured, one, you're gonna have to have administered configuration for your to do the setup. So under CMD, you're gonna run as administrator. So that's one thing. The other one that we're gonna need to download, it's gonna be this the CMake as part of the configuration. We're gonna also have to download this the secure provisioning tool here. This tool is what allows us to write to our board. So those are the only things that you kind of need. And then things like, access to Git and the internet and Python. Python 3.10 is recommended. I have 3.13, but other than that, that's pretty much all you need. So for the next video, I'll go on into installing and trying to burn the image into the NXP switch. Cheers, bye.